data at that stage. And again, it can be a location, it can be a humidity, it can be an alert of accident, it can be my fridge needs more bread. It can be anything. It's any kind of unstructured data. And as you all know, then it needs to be somehow transported. And it can go through a mobile network, it can go directly through wires, it can be in a local wireless network, Bluetooth, it can be Wi-Fi, and then go to the wireless or wired internet. These things, the devices and the sensors, and the kind of information they transmit, and the networks that carry this information. This is classic telecoms area. I'm from telecoms, so I'm allowed to say that it's relatively boring. Then what do we do with all this information? And now it starts getting slightly more interesting. So you can, once you collect it from these devices, you take some kind of snippet of information, you transfer it, you need to store it somewhere. You can store it on your local own proprietary server, you can store it into cloud, you can store it directly into blockchain in an encrypted way, you can store it anywhere. This is kind of where the telcos and the ICT players are playing. Again, I'm not going to talk about that today either. Once it's stored somewhere, in order to create some value out of raw information or raw data, you need to do something with it. You need to somehow process it. The typical places where you process it, again, it can be your proprietary algorithms. It can be a billing system in a telco, for example. It can be a financial system. It can be anything. It can be your own proprietary services and business logic that does something with the collected information. Or it can be passed on through external services, through APIs and so on. And it can be passed on to decentralized distributed apps, like dApps nowadays, as they call it. Now, when all these can do things with the information and with the data to create some value of all of that. And we've seen excellent examples today on all these, from the sensors to devices, to the information, to the networking side, to the security side of the databases, to algorithms that do something, to interfaces that visualize. This last part here, how to extract some value out of information, that's an area where the software companies are working. Again, I'm not going to talk about that today. So what I am going to talk about today is how should we use all these technologies? And if I'm listening to the total world and best practices and what the world is talking about, or I'm talking to my own millennial techies in the office, they have a very, very simple view on this. They say, well, why on earth would I put a server in the office? Because there are servers everywhere. Or actually, why do I even need a server? I can just put it to blockchain and distribute it. And that sort of resonates and makes sense. Why should everybody have a box of metal in their office? The other part is to say that, hey, you know what, if we need to do some intelligent stuff on this, this information that we collect, do we really want to hire 1,000 PhDs to do algorithms? Or should we just use services that are already there, built by super clever people somewhere in the world? Doesn't that make a little bit more sense? And I guess everybody's sort of nodding, yeah, Antti, that's good stuff. This is obvious. But I'm pretty sure that in all of our offices, we also have the other people who say, whoa, 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 whoa. We need to have that server. It's really important we have it here, otherwise it's not secure. We should not send stuff to cloud. We should definitely not put it to blockchain, it's anonymous and scary. And they say that we do unfortunately need to build these algorithms ourselves and the business logic ourselves, because we collect so much sensitive information. I'm not going to send it to United States or Europe for being processed. That's way too sensitive. So who's right? Is it the millennial, the cloud and the blockchain and the API and the dApps people? Or is it the let's own this so we can control it people?
Implementers of IoT across the world today. So, there we go, first slide up. Innovation technology. You've been listening to transformation. How businesses and verticals are doing various transformations in their environment sets here. You know, you talk about the car industries, we talk about manufacturing, the environment sets there, utilities and government orientation there. What about agriculture as well? It says hopefully. There we go. But they're all transformations about what IoT can do for us in terms of driving either more greater components of it or reducing some of the costs. One of the things also is that we really need to understand how it's growing. Gartner and IDC have got some various sets of data. I pulled these slides out from them the other day. One of our colleagues earlier on said about 50 billion. Actually, I think at the moment they're talking about 20 billion. If I look at IDC, it's about 28 by 2020. If anybody's familiar with SoftBank, which is more of a group out that does out the Asian components there, they look a bit further forward in terms of their implementations. And by 2035, they're looking at a terror environment set there. So their predictions is much further forward than Gartner and IDC. But how they actually, where are we on this actual curve in terms of this adoption component? Well, actually, we're pretty well early adopters at this moment in time. We're adopting some of the technologies and trying to transform ourselves to our business environments. But we're probably just in the first section of it, maybe the 15% environment sets there. We've got this chasm to actually go and jump over and then start actually doing these sort of the major implementation environments. So we've got a fair distance to go. Another slide from Gartner, by the way. This one isn't really about security. This was done about a year and a bit ago, and really, they were asking about IoT and what are the biggest concerns. Security came top. If you also look at it, their privacy also came pretty well high up on the list of big components there. So, part of this presentation is about security, not necessarily IoT devices, but actually how we're going to deal with transporting the actual content and the data around. First off, how do you think an attacker actually creates his think bod or device bod component set there? Well, the first thing he does, he'll do a whole lot of recon. He'll go and have a look for what his resources that he can actually get to actually go and use an attack environment set for. Commonly that means that he'll actually scan the whole of the internet. He'll go and pick up all of the actual data he possibly can and look for any brute force components and everything else there. Then he'll start to install, he'll start to actually create a platform or a thingbot, which is commonly talked about these days, and start to install and gather his resources together. Only then will he actually start to consider his attack and what he's actually going to attack. And there's really two sort of things that he will attack. And one of them is the denial of service, or volumetric. And you've all heard about some of these ones in the press over the period of time. But the other ones for IoT are slightly different. We've got different types of attacks and different things which we need to consider. Because these objects are now going to be, or devices are going to be there for a longer period of time, if they're being protected with an SSL environment, what about the cipher? How do we manage the ciphers there? How do we actually look at a compromised item and realize actually it's resource depletion? I've got a couple of customers that have got equipment that's out there for 7 to 8 years. That's the design specification. What happens if it's